Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, my name is Muhammad Hamdan Izzuddin bin Siam. So, I'm from Group 4 from the Section 1. So, today I will explain or present about the methodology of the modern tools that used for our group projects. So, here is the list or the name of our group members. So, the next is the explanation or the introduction of the modern tools. So the modern tools here that we use is MATLAB. So as we know, MATLAB is the one of the best choice that application that students use for running a coding and to find the result for our group project problem and to solve the problem so we can know the final result. So the next one is the parameter of our group. So as we can see, we got two design here. So for design 1, the mass 1 and the mass 2 is different, which is 19.8 for mass 1 and 59 for mass 2, and the K1 and K2 is different too, which is 200 and 600. And for design 2 is we got the same mass as the design 1, but the value of the K1 and K2 both are same. So this is our parameter that we need to use to find the lowest frequency and the highest frequency. So at the below, as we can see, this is the equation for the lowest frequency, which is we need to find the K inverse multiplied by M. So we can, after we can get the value, we can key in into the MATLAB. Then we multiply with X, which is in this problem, the X value is negative 2.9 and 2.1, negative 2.1 and 0.9. So the below is the equation for frequency, which is the same, just the change, which is before this we use K inverse, now we use M inverse multiplied by K. Then after we key in into the MATLAB and multiply by the X value that I said, which is negative 2.1 and 0.9. So the next one is the result for the design 1. So as we can see, after we insert the value of K inverse multiplied by M, then we multiply by negative 2.1 and 0.9. So this is the iterations and the eigenvalue after 5 iterations. So the eigenvalue is 0.1032593. This is for the lowest frequency, the value of lowest frequency for design 1, the eigenvalue. So the next is design 1 but for higher frequency. So as we can see, we do the same thing as we do at the lowest frequency, which is we just need to multiply M negative 1 which K, then we multiply we multiply with X, which is negative 2.1 and 0.9. So the iteration for this design for high frequency is 3, and we got the eigenvalue is 17.20648977. So the next one is for design 2, which is design 2 we use the same method, but maybe there is some change at the K inverse and M value, because the M inverse may be same, but the M value is maybe same, but the K is maybe changed because both of the isolator use the same value. So we use the same method to calculate, which is for the low frequency we just need K inverse multiplied by M multiplied by X. So after we key in into the MATLAB, so after we run, so we get the 5 iteration and the eigenvalue is 0.28449957. So this is the eigenvalue after we run it for lowest frequency. And the next one is the high frequency for the design 2. So we use the same method to the equation for the high frequency, which is m inverse multiplied by k. Then we insert into the MATLAB. Then we insert we key in the x value, which is negative 2.1 and 0.9. After we key in the values, so we run. So after we run, we got 4 iterations, which with value eigenvalue is 20.79915,155. So as we can see, after we run all the design in the MATLAB, we can see that our eigenvalue value is same as the methodology theoretical. So the calculation is using the modern tool for the methodology for the calculation is more easier than methodology theoretical that we do self calculations, which is using the model tool we can avoid the error and the mistake in the calculations. So that's all from our group. I hope you can understand our presentation and our explanation about the model tool that we use to solve our problem. So thank you.